Hey there, welcome back to Quite Basic Math. Now we'll be looking at how to find the square root of surdical expressions. We have two surdical expressions here, 5 plus 2 root 3 and 3 minus root 10. Now the way to go about it is, what you are looking for the square root of the surdical expression is what determines what you will set on the right hand side. Now what they're asking us to do here is simply this, okay? We're simply asked to find this. In the first case, okay, what they ask us to find, they say find the square root. That's saying the square root of 5 plus 2 root 3. That's the first thing they're asking us to do. And you must understand that the idea behind this is you are looking for a solution, since it's the square root you're looking for, and this is a semi-surdical expression. So your result should look like a surdical expression fully. So what you do is, if you have plus here, you just say root a, okay, plus root b. Okay, you say root a plus root b. Now after doing this, the next step is you square both sides. What we're just simply looking for is a and b. When you square both sides, what you have will be 5 plus 2 root 3, to take away the square root you have on the left hand side, equals to root a plus root b all squared. And if you square this will give us a, this one, plus 2 root ab plus b. Okay, so you compare it to what you have on the left hand side. This left hand side has a real number section and a surdical section, or a surd section. So you split it that way on the right hand side. So you have a plus b plus 2 root ab. So you compare both sides of the equation. So comparing the coefficient, if you compare both sides of the equation, you see that this part and this part are in tune, this part and this part are in tune. So this implies that 5 equals to a plus b and 2 root 3 equals to 2 root ab. And from here you can see that we have a simultaneous equation. You can call this, you can say a plus b equals to 5 to be equation 1, and then 2 root ab to be 2 root ab, this can be simplified further. You agree with me? If you divide both sides by 2 and you square both sides, what I mean is, if you divide both sides by 2, you will now have root b equals to root ab. And if you square both sides, this implies that 3 equals to ab. So you have a plus b equals to 5 and ab equals to 3. This is our second equation. We now have simultaneous equation. So whenever you are asked to find the square root of a surdical expression, it always leads to a simultaneous equation. So from here, you can decide to say a to be equals to, using substitution method, from equation 1, you can say a is 5 minus b, right? And then you substitute it into equation 2. That means that you now have b into 5 minus b equals to 3. Since a is 5 minus b, you just put it here. And then you have 5b minus b squared equals to 3, and this will be b squared, if you bring everybody to the right, minus 5b, okay, plus 3 equals to 0. So if you use your algebraic your quadratic formula to find b, it means that your b will be equals to minus into minus 5 plus or minus square root of minus 5 all squared minus 4 into 1 times 3, right, over 2a. How did I get that? Over 2 into 1. Don't forget the quadratic formula, minus b plus or minus square root of b squared minus 4ac over 2a. I use quadratic formula because this is already looking like something that will not be easily factorizable. Okay, so your b now will be equals to 5 plus or minus square root of 25 minus 12, okay, all over 2, and this will be equals to 5 plus or minus root 13 over 2. So this is b. Now this is quite ambiguous, but this is b. Now to find a, right, so since a equals to 5 minus b, implies that our a will be 5 minus what you have here, 5 plus or minus root 13 over 2, and this will be equals to 5 minus 5 plus or minus root 13 over 2, okay, and then the LCM is 2, right, and then you have 10 minus 5 plus or minus root 13. You can just open the bracket like this. and then you have your a to be equals to 10 minus 5 in the bracket minus plus root 13 over 2. So this will be 5 minus plus root 13 over 2. So you can see a and b are mirror images of each other. So that means that the square root now of what we asked to find, don't forget we have to find the square root of 5 plus 2 root 3. You just simply put in your values of a and b, 5 plus 2 root 3. So you just put your values of a and b. Don't forget a is this, and we said our solution should be square root of a. So that will be square root of 5 minus plus root 13 over 2 plus what was b, square root of 5 plus or minus square root of 13 over 2. So what we are saying in essence is you have two solutions, okay, for the square root. Don't forget, when you look for the square root of a number, your answer is plus or minus. So it's two solutions. Now the first solution, if not even 4, because what I can see here, there's a plus or minus here, there's another plus or minus actually when you have this square root. So we have about 4 solutions. But let's see, practically we have 2 solutions. The first is square root of 5 minus root 13 over 2. When you have minus here, you must use plus here. Plus square root of 5 plus root 13 over 2, or a second solution, square root of 5 plus root 13 over 2 plus square root of 5 minus root 13 over 2. So like I said, mirror images of each other if you use one or the other, which clearly you can see they are actually the same thing. So this is the square root of this. This is square. It is quite clumsy because this question was just abstract. Okay, I decided to use a question that is not general, because most questions will just give you a perfect answer, but I wanted you to see that not every question has to look perfect. Okay, now let's look at the second question, 3 minus root 10. You have to find the square root of 3 minus root 10. The game is quite different. Why is it different? Because this time around you are dealing with a negative number. So if you are looking for a square root of a negative number here, what you need to do is also mimic that. So you have root a minus root b instead of root a plus root b like we had initially. So if you square both sides now, square both sides of your radical, what you have will be 3 minus root 10 equals to root a minus root b all squared. And then this will give us a minus 2 root ab plus b. Plus b, yes, plus b. So this will be 3 minus root 10. Just follow the same procedure, a plus b minus 2 root ab. In so doing, this implies that our a plus b is 3. You can call this equation 1. And minus root 10 is minus root 2ab. Okay, minus 2 root ab. So this will imply that our final answer then will be, if you square both sides, you have 10 equals to 4ab. Right, this implies that our ab is actually equals to 10 over 4, which is simply 5 over 2. So your ab is 5 over 2. If your ab is 5 over 2, for us to find a and b, just like we did initially, you say a equals to 3 minus b, right? Or b equals 3 minus a. Anyone you want to substitute, then you put it back here. So this implies that you have b into 3 minus b equals to 5 over 2. Alright, so if you simplify this further, you have 3b minus b squared equals to 5 over 2. By multiply through by 2, and we have 6b minus 2b squared equals to 5. Now this implies that 2b squared, if you take them to the right, minus 6b plus 5 equals to 10. 2 times 5 is 10. Clearly, again, this kind of a question you cannot simplify with factorization, so we'll go for quadratic formula. So our b now will be minus into minus 6 plus or minus square root of minus 6 all squared minus 4ac. A is 2, b is 5, c is 5 over 2 times 2. How do I know a is b? B is, what am I saying? The general quadratic formula follows the general quadratic equation ax squared plus bx plus c equals to 0. So this is what guides this. Alright, so your b now will be equals to 6 plus or minus square root of 36 minus 2 times 5 is 10, 10 times 4 is 40. Okay, this particular question will give us a complex solution. and we are dealing with operation with real numbers. So okay, so this particular question will give us a complex solution. If you want to understand the idea behind complex solution, you should check out my previous video on complex numbers to guide you through it. And this will be minus 4 all over 4. Okay, I'm going to finish it, just that one answer will be in complex domain. So our b now will be equals to 6 plus or minus 2i, okay, over 4. How did I get I? Check my previous solution. So our b now will be equals to 3 plus or minus I over 2. So this is b. Then our a will be equals to, since we said a is 3 minus b, means that our a will be equals to 3 minus b, where b is 3 plus or minus I over 2. So our a now will be equals to 3. The LCM is 2, so that will be 2 times 3, which is 6. Then you have 3 plus or minus I. Okay, if you open a bracket, you have 3 minus plus I over 2. So this is our a. So our final square root now, the square root of 3 minus root 10 will be equals to, it is root a minus root b, don't forget, as our square root that we assume. So we have root 3 minus plus I over 2 minus root 3 plus or minus I over 2. And what this is implying is that you have two solutions, which is either 3 minus I over 2 minus root 3 plus I over 2, or your solution is 3 plus I over 2 minus square root of 3 minus I over 2. Either one of these guys is the square root of this surd. So this is an advanced level mathematics, not the regular one you might come across in your high school. Please do well to like, subscribe, and comment if there are any gray areas that you have. And then if you want to probably have a session with me, you probably want a one-on-one live tutorial session, please do well to also put it up in the comment section so I can link you and give you a link to where you can meet me and discuss how we can have our live session together. Alright, I hope you've learned one or two things. So this is Surds in a basic form. Do well to solve more questions. Whenever you have questions, do well to comment, and I'll always get back to you as soon as I can. So operations with real numbers would always involve surds in most cases, and handling surds involves understanding the rudiment of surds, from simple surds to compound surds to rationalization of surds to surdical expressions to understanding how to find square roots to understanding how to convert whatever surds you have to from irrational to rational, as the case may be, and understanding how to go about your algebraic processes. I hope you've been able to learn one or two things in this video lesson, and I hope I see you next time. Bye for now.